Lesson 14, disproving conjectures with counterexamples. We talked about conjectures back in an earlier lesson. You remember what a conjecture is?
Statement.
A statement that is believed to be
True.
true. So, a conjecture is a statement that is believed to be true but has not been proven. Okay? So, I may have some ideas that I say I believe are true, but haven't been proven. Give me an example of a true statement that appears to be true but hasn't been proven. Yes, an if-then statement. Yes.
If it's pink, then it's a flamingo.
So if it's pink, then it's a flamingo. How do I disprove that statement, Victoria?
If it's a flamingo, then it's pink. Like, don't you reverse it?
Okay. Yeah, I mean, I can do that, but how do I prove that that statement is wrong, Sierra?
Well, so the other day some girls were wearing some pink. So
Okay.
it's not a flamingo.
So,
I know
if
more
girls are
than
wearing
flamingos.
pink, then they're
Whoa,
flamingos?
what's all this stuff on top? Looks way better on there.
Yeah.
What's
What?
all that?
What?
A counterexample.
Counterexample is I'm trying to record, so I'm coming around here.
Oh,
If
okay.
it's a sea star, then it's pink, or it could be a sea star.
Okay, so not
Give the mic to me.
everything that's pink is a flamingo. And are all flamingos pink?
No,
Are
What-
they?
maybe.
Why are flamingos pink?
Because they eat the shrimp thing.
Because they eat the shrimp
Isn't there like
things.
an albino flamingo?
If they're not eating shrimp, they're not going to be pink.
Yeah,
It's like the people who eat too many carrots, they start shriveling.
Yes, it's like people that eat too many sweet taters and carrots.
Whatever color they're eating.
What if we fed them like blue?
So, look at the warm-up activity on page 84. Number 2. What is the hypothesis of the conditional statement below? If it rains today, the road will be slick. What's the conditional statement?
The roll will be slick.
The road will be slick is the conditional?
Sure.
All right. Andrew said it rains today. That's the conditional statement. That's the first part. That's the hypothesis. The second part of it is your conclusion. So, if it rains today, then the road will be slick. So that's your conclusion. That's what you're basing. You're basing your conclusion on your hypothesis, or on your, yeah. So look at the third one. What is the conclusion of the conditional statement below? If a triangle has one acute angle and one obtuse angle, then the remaining angle is acute. What is the conclusion?
The remaining angle is cute.
Yeah, the remaining angle is cute. Or acute.
It's cute.
All right. So, let me give you another conjecture here. If two lines are both intersected by a transversal.
That's really cool.
All right, so I've got two lines, and I'm going to intersect them with a transversal. Okay? So that is the hypothesis. The conclusion is, then they are parallel. So if two lines are both intersected by a transversal, then they are parallel. My transversal is which line? The pink one. The purple lines are my two lines. Okay. So is that conjecture true or false? Why?
Because look, they're not parallel.
They don't have to be parallel in order to have a transversal. And we had talked about that earlier when we were talking about transversals. So, a simple way to prove that a statement is not true is to use what is called a counter example. So if you can find one situation where it's not a true statement, you've just proven that your conjecture is false. Okay, so for instance, let's put a geometric conjecture up here. If a triangle is isosceles, whoops, told you I can't spell that, then, I call these if-then statements. The book calls them, conjectures or all that other stuff, but I call them if-then statements. Then it is, then it's acute. So again, if
Cursor.
triangle, that's because I can write it faster, is isosceles. Oh yeah, I did, didn't I? There. Then it is acute. Okay, so there's my conjecture. Is that a true or false statement? You don't necessarily know off the top of your head. So what you need to do is you need to figure out if you can come up with a counterexample. Something that makes it not true. If you can't, that doesn't necessarily mean that it's a false conjecture. It just means that you're stupid. No, I'm kidding. It just means that maybe you can't think of one, or you haven't tried all options. You forgot one or you missed one. All right, so how would I figure out whether that is a true conjecture or not? Victoria?
You said if it's acute, then it's an isosceles. So, but an obtuse could also be an isosceles triangle.
Okay, an isosceles triangle, if you remember,
I think it's right.
has two line segments that share a vertex that are congruent. Okay, is it possible to draw an obtuse triangle
Yeah, it would just be fat.
that...
Just
Okay, so let's draw. So you're saying it would look like that? And then we could make those two the same? Okay. So, you've taken one example and proven this conjecture as being false based on an example that you drew. Another example would be that you can draw a triangle that is 90 degrees. Same thing. So isosceles triangles can be acute triangles, they can be right triangles, and they can be obtuse. So my conjecture says if it's isosceles, then it has to be acute. There's no other option. And you guys said no. Let me give you an example here of where you're wrong. Okay. One thing that I want you to remember, do not use conjectures on your parents. If you do this, then I will beat you. Don't get smart and come up with a counterexample. Okay? If you go to town, then I will take the car away from you for a year. And you're like, I'm going to prove that wrong, Yeah. So that's called being a smart aleck to your parents. So, okay. Yes, never do that. My brother used to do that all the time. He's an idiot. Okay, so talking about algebraically. What we're doing here again is we're looking at the statement and seeing if we can find a counterexample. Okay? So, the hypothesis is 5x minus 10 equals 15. If that is true, then 2x plus y is greater than 9. Okay, so if 5x minus 10 is 15, what must x equal? 5x equals 25, divide by 5, divide by 5, x equals 5. You guys know how to say 555 in German?
Yeah.
Okay, say it for me, Elias.
I don't want to. It sounds dumb.
No, it doesn't. It's awesome.
He says it all the time.
555 in German, Victoria. You want to hear what it is?
Sure.
555. Seriously.
Say that again.
500. Fünf is written like this.
See, they just talk like us, they just come off the word.
Okay, those are umlauts. Fünf is 5. Eins, drei, eins, zwei, drei, vier, fünf. Fünf is 5. So 555 is 500 with a T at the end. Fünf und means and. 50. So it's actually transliteration exactly. It's 500, 5 and 50. The 5 and 50 is 55. So, yeah, 500, 550. So I'm teaching over at. Okay, so they just missed that fun story, but that's okay. And now it's even worse because they know I told a fun story and they don't get to hear it. All right, so.
Recording right now.
Yes, I am. X equals 5. So if 5x minus 10 equals 15, meaning if x equals 5 and makes that a true statement, then 2x plus y is greater than 9.
What's y?
Okay, good question. That's our next step. We have to find out if that's true. So, 2 times what? What is x? Plus y is greater than 9. So 10 plus y
It's true.
is greater than 9. Shut up back there. Y, I'm kidding, Ben, is greater than negative 1. So if x is 5,
Where'd you get the negative 1?
I subtracted 10 from both sides.
Ah, my bad.
Yes.
I missed that.
Okay, so if x equals 5, then y is greater than negative 1. Look at that and see if it's true. Is y greater than negative 1?
Yeah.
Is it possible for you to put 5 in there for x and pick a number that is not greater than negative 1 in there and still have that be a true statement? Let me erase a bunch of stuff so we can try, because this is like so fun. All right. So what I'm saying here is 10 plus y is greater than 9, right? Because I'm putting 5 in there for x. 5 minus 2 is 10. So there's my statement. Is there a time where we can put a number smaller than negative 1 in there for y and get a number greater than 10? Right now, the conjecture says I have to be able to put a number in there that's greater than negative 1. Give me a number greater than negative 1.
0.
Okay? How about negative 6? No, that's smaller. It's still 6, but it's in the other direction. Okay? So, on a number line, if this is negative 1 and this is 0, we're saying here that any number to the right of negative 1 will make that answer greater than 9. Are there any numbers to the left of negative 1 that will make that true?
No.
Okay? So, Ben says no.
Well, actually.
What happens if I put negative 2 in there? So I get what? Okay, so you just gave me one number, but you realize if you start plugging in lots and lots of other numbers, it's not going to happen. Okay, so you can say, yes, that's a true conjecture. All right, so let's look at an application here. Let's get rid of my stuff. Page 86, top of the page, example number 3. We've got an application from astronomy. What's astronomy?
Study of the stars.
Study of the stars. Okay. So it's saying use the data in the table to prove the conjecture false. So they're already telling you that the conjecture is false. And they want you to be able to use the information there to prove it. All right, so if a planet orbits our sun in a year, if a planet orbits our sun, its year is proportional to its distance from the sun.
Yeah.
Okay, its year is proportional. Whenever you see proportional, you put a divide sign. And you put the number before, or you put the information before proportional above year over distance. Okay, I'm top of page 86. So that's a good way to remember the whole proportion thing. The word, the noun before proportion, in this case the year, goes on top. The word distance goes in the bottom because it follows proportion. So the proportion is the division sign. So year is proportional to distance. Okay, what it's saying is that the year is proportional to its distance. They're saying that if I were to take the fraction, let's look at Earth. Okay, Earth says the orbital period. How long is the orbital period? How long is a year?
365.
365 days. Over distance.
93 million.
93 million. Let's just do 93 right there. Well, we have to do million. Okay, so take your calculator and find out what that is. Thank you. It's a number close to 3.92. All right, so what they're saying is, if the planets, how long it takes for a planet to go around the sun, how many days it takes for it to go around the sun, if you take that and divide it by how far away it is from the sun, you will consistently get the same proportion, the same number. Okay? I mean, that would be pretty cool.
Why do we care?
We don't. Okay, so let's look at Mars. How many days are in a year?
687.
And we put it over distance, which is how far?
142 million.
142 million. When we do the division there, we get approximately 4.84. Did we prove the conjecture wrong? Yeah. Because these two numbers here are not the same numbers. So therefore it's not proportional. It has nothing to do with the number of days it takes for the planet to go around the Earth or the sun. It is not proportional to the distance from the sun. Okay? A lot of people used to think that it did. But you just get that information and you get two different numbers there for your proportion, and it's wrong. Interesting, Saturn. Look how many days there are, how long their year is. 10,700. Divide that by 365, Michael. Yes. Golly, are you kidding me? You have a calculator. 10,700 divided by 365.
29.3150.
Okay, so what I'd like you to do is look at page number 86. And let's do a couple of these practice problems here. All right, very first one says, if line A is perpendicular to B and C. Do you have a drawing of that?
No.
No, so I'll have to put a drawing up here on the board. All right, if line A is perpendicular, all right, so we'll call this line A, and this B, and this C. Okay, so if line A is perpendicular to line B and to line C, then lines B and C are perpendicular, or I'm sorry, are parallel. So they're saying that if line A is perpendicular to line B and it's perpendicular to C, then B and C must be parallel. Okay, so that's the conjecture. What's the hypothesis?
If a line is perpendicular to line B and C.
Okay, line A is perpendicular to line B and C. What is the conclusion?
Then B and C are perpendicular.
Exactly. Okay, find a counterexample.
Aren't they parallel?
And it says they're not perpendicular, so it's wrong.
Okay, so all you have to do is find an example that's different. And the example that both Sierra and Victoria threw out there was, aren't they parallel? Yeah. So if they're parallel, they're not perpendicular. So you've just proven that B and C are not perpendicular. Okay? So you just give me one example to prove it false, and you've just blown the
So you
conjecture.
can just say no, they're parallel.
Yeah.
Okay.
Yeah. Okay. Look at the next one. If x squared equals 9, so we've got a little if statement there, then x equals 3. All right. What's the hypothesis? Okay, x squared equals 9. You don't have to say the if. It's just x squared equals 9. It's not wrong to say if, but what's the conclusion? X equals 3. Okay. Can you find a counterexample that makes that statement false?
Teachers, at this time, could you please?
Again. What is the number that works?
3.
3. 3 squared equals 9. Can we square any other numbers out there in the whole history of the world and still get 9?
No.
And then,
Negative 3.
Oh, man.
Oh, Ben.
So, Ben is hogging the questions. All right. So, yes, Ben is correct. Negative 3. If you square that, you also get 9. So there is a counterexample that makes that a false statement.
good job.
Yes. So you win the prize.
I'm the gold star of the day.